but let's get into our lesson. So on Monday, we spoke about the multiplication rule with exponents. And so we're just going to practice that before we head into division, just to make sure that we all are comfortable and confident moving on with these questions. So what I want you guys to do is I want you to try these three questions here. Answers on the chat, A, B, and C. And what I want you to remember is that when you are multiplying or dividing, we need to bear in mind SNV. Remember, signs, numbers, variables. If we break down our multiplication or our division with signs, numbers, variables, we should do it correctly. So I want you to try A, B, and C here. Put your answers in the chat. Remember, guys, if you want to write an exponent on the chat, what you need to do is say shift and then 6. That will give you a little copy thing. And so you would type, let's say, for example, S shift 6 to get the hat and then 2. And that therefore means x to the power 2. So you can write an exponent like that on the chat so that we know what exponents you're working with.
I see Omomlemo, and who else? I think it's only Omomlemo. Omomlemo does it nicely. I don't even know how to do that in my own computer. It's like 8 to the power 4, straightforward.
Yeah.
Without the copy also. Like, oh, Realeboha also does the same. Okay, guys, I'm talking a lot. Yeah, you can go ahead.
No, to be fair, I saw that on Monday as well, and I was gonna say, how do you do that? But then I felt like a bit of an old person because I didn't know how to do it.
Yeah, I also don't know. I know the copy way, but I don't know how to do that.
Are you on a phone? I don't even know how you would do that on a phone. Yeah, guys, how do you make the small little 4 there without the copy?
Yeah. Didn't they? You can just use the copy. So you press the shift 6 and it will give you the copy, and then you can put it in there. Woo, Melisha also knows how to do the guys. Hook us up.
Yo, guys, yeah, I feel very stupid right now. How do you do this?
Cassie also knows. No way, guys.
I feel like they're now keeping it a secret from us.
Yeah, now I'm gonna be. I have a homework to do.
I'm using the phone, so you just long press. What? I didn't know that you could long press the number and it would do that. Am I just really stupid? Mine's not doing that.
Oh, on the phone. Ah, yeah, it makes sense. Some phones does do that. That makes sense.
Oh, mine's not doing that. Okay, well, I'm impressed with you guys. Well done.
Well done, guys, for finding that out. Well done.
We got so distracted.
Teacher Sam, I'm just gonna let you know quickly that Christy might just join you because electricity is not back.
No problem.
Sorry,
don't stress.
Teacher Sam. Thank
don't
you.
Stress. Not your fault at all. Hey, I'm seeing answers coming through. Let's keep them going. Remember, guys, when you are multiplying, so for example, in question B, you've got 2a times 3a squared. Everything is being multiplied, which means that that 2 and that 3, those coefficients also need to be multiplied. That's where the n comes in from SNV. So just remember, we're working with only multiplication here, so we shouldn't be doing any other operations. Obviously, when it comes to the exponents, we know that we add exponents, but that is because we are multiplying. So just remember that. Well done, everyone, on labeling your answers as well. Right, we shouldn't have any fractions in our exponents. That is not something we deal with at this point. So shouldn't be any fractions. Don't worry. I'm going to give you guys another minute or two, and then we're going to have a look. So don't stress, no problem. It is a good one though to point out because sometimes we do get some answers that we're not 100% sure of, and so it is good just to point out generally we don't get fractions in our answers. Alrighty. Okay, anyone want to raise their hand to help me with question A? Oh, Chantal's on it. Chantal, tell me, how do I do A?
Good evening, ma'am.
Hello, how are you?
Fine, ma'am. In A, I got A to the power 4.
Excellent, well done. And how did you get that power of 4? What did you do?
Ma'am, I said A times A equals to A, and then I said 2 plus 2 equals to 4.
Perfect. Okay, so guys, remember our first law of exponents tells us that when we multiply the same bases, I don't know if my fingers are now on your camera, but whatever, the same bases, we can add the exponents. And so that's exactly what Chantal's done there. We had the same basis of A. So what we can do is we can say A to the power 2 plus 2 and add those exponents. And that gives me A to the power 4. So just remember our exponent rules that we have already learned. We can add the exponents when we multiply. Cool, well done, Chantal. Latish, do you want to help me with B?
Hello, ma'am.
Hello, how are we doing?
But I'm fine, ma'am.
Good.
Okay, B is going to be 2 times 3, then it's 6A cubed.
Excellent, well
Squared.
done. A cubed is right. So guys, remember, this A over here has an exponent of 1. We don't have to write the exponent, but whenever we've got a variable or the letter sitting by itself with no exponent, we need to remember there is an exponent of 1. So if we now apply our SNV to this question, a positive times a positive is a positive. 2 times 3, as Litesh said, is 6. And then when we get to our exponents, remember we've got A times A squared. So in total, we have got 3 A's that we are multiplying together. And so that's why we end up with A cubed. Very nicely done, Litesh. Well done. And guys, remember, you are multiplying. So these coefficients, you are multiplying together. You're not adding. I saw some 5A cubes on the chat. Make sure you are applying the correct operation here. Right, China, help me with C.
Hi, ma'am.
Hi, how are you?
I'm good, and you?
I'm good, thank you.
Okay, so I times 2x, I times 2 and 3, and then I
Okay.
got negative 6x, and then I said x, and then I said 2 plus 1.
Mm-hmm. So that's your
And then I
exponent
wrote,
for x.
yes.
Good.
And then wrote y, 1 plus 3.
And that gives you an exponent of?
Negative 6x3, and then y, 4.
Perfect, well done. Okay, guys, so again, if we apply, if we apply our SNV here, negative times a positive is a negative. So that is why Shana gave us a negative answer. 2 times 3 is 6, giving us the product of our coefficients. And then we need to remember those variables. So if we look at the x's, remember we have to work with the same bases. X squared times x to the power 1, we add those exponents. That's why Shana gave us x to the power 3. If I then move on to my y, I've got y times y cubed. And so by adding those exponents, I'm ending up with I'm ending up with my y to the power 4. So remember to not rush into these questions, break it down, and remember your SNV, guys. If you apply SNV, you will hopefully properly and accurately find your products or your quotients if you're dividing. But this is all from Monday, so I'm hoping that we all were okay with that. If you struggled with C, that is absolutely fine. C was the more challenging of the 3 questions. But just remember, start with your numbers, then move on to your variables, and we can only add exponents, like I said here, when we have the same bases. If we don't have the same bases, we can't do anything. All right, Didntle, there you go. I'm going to leave it there for you so you can take a screenshot, and then we're going to have a look at our next law, which is dealing with division.
Yeah, out of curiosity, how many of you got full mark? Or actually just out of 3? You can just put a number out of 3. How many did you get? I just want to see where we are. How many did you get, guys? You can say 0. It's okay. We're here to help you. Fatma, well done. Woo, well done. Woo, well done. Yes. Oh, wow.
Well done, guys.
Yes,
and remember,
my
it doesn't matter if
people.
you didn't get 3 out of 3. That's cool.
Yeah.
This is why we're here. We're here to learn. But as long as you're making those corrections, that's what we care about.
Well done, my people. Well done, guys. I'm so proud of you. Oh, they're doing
Your
amazing.
power come back, Yolanda.
Yes, that's why I'm here.
Yeah. I'm so glad.
happy. Oh, it nearly shocked me today.
Oh, shit.
I was traumatized.
Oh, no.
Didn't you have a question? I see your hand is up.
Oh, no, I muted you. I'm so sorry, didn't Leah. That was my fault. I thought I was trying to unmute you. My bad. So sorry. Try again. There we go. Okay. I'm not touching.
Can you hear me, ma'am?
Yes.
I can't see the sum for C, ma'am.
Oh, because I've scribbled all over it.
Yes, ma'am.
So sorry. There we go. Thanks, didn't Leah.
Well done, guys. We're so proud. We're nailing this. Another question.
Mange Mtanda. I'm hoping I'm saying that right. Yes. There we go. Okay, hopefully I don't mute you as well. There we go.
Ma'am?
Yes.
For A,
Yeah.
if I said 1A to the power 4, would that be right or wrong?
No, that's absolutely fine. So if you put the coefficient of 1 there, perfect. No problem at all.
Oh, okay, ma'am. Thank you, ma'am.
So generally we don't write the 1 in front, but it's not wrong. So if you've put it there, you're not going to be marked wrong and you can keep it there. That's fine. Right, guys, well done. So let us move on to our rule for today, which is dealing with division. So remember I said to you on Monday, the rainbow block is where we're going to have all of our rules. So the rainbow blocks in these lessons, super important. We need to know these things that I'm writing in here. So I'm going to write our law, and then I'm going to explain to you why the law exists or why the rule exists and why we can use it. So our second law of exponents, which deals with division, as I've said many times now, is that when we are dividing with the same bases, we can subtract the exponents. Right, now, as we go through these examples, I'm going to show you a slightly different way to do it, mostly because I find it easier. We're going to have a conversation about where we put our answers in the numerator or in the denominator. And personally, I just find it a little bit easier to cancel, but we're going to chat about all of this as we go along. It also doesn't matter if you choose to rather apply the law. I'll show you the law application each time anyway, so that you can see it. You get the same answer. And this is actually why I quite like exponents, because especially as they start to become more complex, you can do things in so many different ways and get the answer. You can apply laws in different orders and still get the answer. And so that's what is quite nice about exponents. We don't all have to do it exactly the same way to get the right answer. And that's why maths is so cool. There's different ways to do the same thing, get the same answer, and we need to explore those different ways. Alrighty, so law 2, when we divide the same bases, we can subtract the exponent. So much like law 1, we need to have the same bases. That's very important. So let's have a look at an example of why this law exists and why I can subtract the bases. So if I had, for example, x to the power 7 divided by x to the power 3, right? If I imagine this as a fraction, I've got x to the power 7 over x to the power 3. Now my rule says, because these bases are the same, I can subtract the exponents. So we'll get to why that is in a second. If I didn't know this law and I asked you to simplify this, we know that technically we could expand both of those. Now, what I mean by expand is I'm multiplying 7 x's in my numerator. Make sure I've got 7. Yeah, I've got 7. And I'm multiplying 3 x's in my denominator. So I could write them all out. And I know from fractions that I can cancel like factors in my numerator and in my denominator. So I can cancel 1x with 1x at the bottom, a second x at the top with a second x at the bottom, a third x at the top with a third x at the bottom. And once I've canceled out all available x's in my denominator, I'm left with 4 x's in my numerator. Now I know that if I'm saying x times x times x times x 4 times, what I'm left with is x to the power 4. And so what I've done is I've simplified my initial sum, x to the power 7 divided by x cubed. Now, obviously, guys, we don't want to have to write out x times x times x times, no, too much. We don't want to do it. So mathematicians found that there was this rule that they could apply because of this cross-canceling that actually works every time when we divide. So my law says to us that we can subtract the exponents. Now, very importantly, when we are subtracting the numerator minus the denominator, sorry, I can't spell tonight. So basically the top minus the bottom. And that's a very important thing to remember. We always take the top exponent minus the bottom exponent. And so if we take exactly the same question, x to the power 7 divided by x to the power 3, and we apply this law, we would have x to the power 7 minus 3. And we know that 7 minus 3 is 4. I get exactly the same answer as if I expanded. Exactly the same. It's just now shortcutting the process to just subtracting the exponents rather than writing it out. And so this is why our division law exists. If we were to cross cancel, we are able to cancel a certain number of x's that we have available to us in the top and the bottom, and we then have a remainder. And this is how we can go about doing this. Now, personally, I prefer cross-canceling. I don't expand, and I'll show you how I do it in a second. I prefer cross-canceling. But if you apply the law, that's absolutely fine. Like I've just shown you, it gives you exactly the same thing. Right, so take a screenshot. We're going to have a look at an example too.
Yep, take screenshots or take pictures using your phone if you are busy with your computer, just so that you can be fast. I see Avuzwa Mbochelwa. I'm not sure if I'm pronouncing that nicely. Are you new to Watobe? If you're new, we welcome you. And we are saying welcome. And please don't hesitate to ask if you have any questions, okay? Don't get stuck. You always need to ask, okay? We just wanted to say hello and we recognize you that you're there. And anyone who's new, okay? I might not know who's new, but I can pick up some few that I knew. Okay, guys?
Alrighty, guys. So let's have a look at some examples. So our first example here, we're just going to keep it nice and easy to start off with. We've got x to the power 5 divided by x squared. Now, if we just apply our law, we know that we take our top exponent and we subtract the bottom exponent. So we will have x to the power 5 minus 2, leaving me with x cubed. So that's absolutely fine. No problem with you doing that. By all means, go for it. Another way we could deal with this, though, is we could cross cancel. And this is the method I personally use. I like this more, but this is also my personal preference. I know that I have got 5 x's in my numerator. So 5 x's at the top. And I've got 2 x's at the bottom. Now, what that means is I can cancel. I can cancel all 2 of my x's in my denominator with 2 x's in my numerator, leaving me with 3 x's at the top. And so when I simplify this, I still end up with x cubed. The same answer as what I got when I applied my law. So however you choose to do it is completely up to you. There's no right or wrong way to do it. Like I said, I personally prefer cross canceling, but you don't have to do what I do. Just because I do cross canceling doesn't mean it's the way that makes sense for you. So you need to decide what makes more sense, and you need to use that method. If you want to subtract the exponents, awesome. We're going to chat about some, let's not say issues, but something that you might encounter that you need to be aware of if you subtract exponents, which is cool. But if you want to do it, completely up to you. All right, so let's have a look at a second one. I will come back to A so you can take a screenshot, don't worry. But let's have a look at question B. So we've got 2x to the power 5y cubed divided by x squared y. Now what we need to be careful of here is that we have got different bases. We have got a base of x and we've got a base of y. And remember, my law says to me that I can only subtract exponents when my bases are the same. So I need to be careful. What I also need to remember is that because I've now got coefficients here, I need to apply my SNV. So if I start with signs, I've got a positive divided by a positive. My answer is going to be positive. I've got no issues there. Then I move on to my numbers. Now remember, guys, there is actually a coefficient of 1 here. So in terms of my numbers, I'm saying 2 divided by 1, which we all know is 2. So my fraction in terms of the numbers simplifies to 2 over 1. You don't have to write the 1 there, it's up to you, but it simplifies to a 2. Now I move on to my variables. So if I have a look at my first set of variables, I'm going to start with the x's. If I look at my x's, I've got x to the power 5 divided by x to the power 2. Now, again, you choose how you want to do this. If we choose to apply the law, we will subtract the exponents. So x to the power 5 minus 2, which leaves me with x to the power 3. Now, because I've got a fraction here, remember, I need to take note of where my leftovers go. My leftovers always go where the biggest exponent for that variable was. So because the biggest exponent for x was in my numerator, my answer of x cubed needs to go into my numerator. If you think about it in terms of expansion, you had 5 x's in your numerator and 2 x's in the denominator. It makes sense that the 3 x's are in the numerator. That's where you had more x's. So just bear that in mind. Then we move on to those y's. So when we look at the y's, we've got y cubed divided by y. Now remember that y has an exponent of 1. So if we're going to apply our law, we've got y to the power 3 minus 1, which is y squared. My biggest exponent of y was in the numerator, so that's where my leftovers go. If you want to think of the expansion side of this, y times y times y divided by y, my leftovers are in the numerator. That's where the y squared needs to go. And so we have gone and simplified our entire fraction here. Now, because it's all over 1, I don't actually have to write it as a fraction. I can just leave this as 2x cubed y squared and write that as my final answer. If you want to write the denominator of 1, go for it. Doesn't make a difference, means exactly the same thing. It's not going to change the answer. But you don't have to if your denominator is 1. If your numerator is 1, you do. But if your denominator is 1, it's fine. You can leave it out. All right, so I'm going to let you take a screenshot of those two. I'm just going to make that a touch smaller. If anyone has any questions at this point, actually, let's do this so I can make it a bit bigger. If anyone has any questions at this point, now is the time to raise your hand and ask me if you're confused about anything. Hopefully we're not too confused just yet, but obviously if you have questions, just say so.
It's your time to shine, my people. I'm like watching you. I hope you got this because the next question is coming from you. Eh? You'll be the one to answer. You see, I'm already choosing my best learners that needs to answer. Because if you guys are not asking questions and you don't follow, we will see when we have to do examples by ourselves. Okay. Another one is busy. Ooh, lowest sure I'm busy. I'm sure you know that I mean you. But yes, you. I hope that you will also be ready. Y'all are ready for us. Oh, Dintle has a question. There we go, Dintle. I'm going to unmute you. Dintle, you can ask your question. You can unmute on your side. Yes.
Ma'am, at the second step, ma'am,
For question
can you
B?
explain? Yes, ma'am.
Yes.
Question B, ma'am. Can you explain how you got that, ma'am?
So when you say the second step, are you talking about this step over here? And of course, my pen's going to choose this moment to not work. This step over here.
Oh, I mean actually the first. Yeah, that one. Yes, ma'am.
Okay. So the 2/1 came from my numbers. 2 divided by 1 is 2. So we leave it as 2/1. We can't simplify it further. Then I have to deal with my x and my y separately. So I said x to the power 5 divided by x squared, and I subtracted my exponents to get my x cubed. So that's where this x cubed is coming from. And then I do exactly the same thing with the y's. I've got y cubed divided by y. I subtract my exponents. Let's just draw a better arrow. I subtract my exponents because I'm dividing, and that's where I get the y squared from. And so I've simplified my entire fraction.
Oh, okay, ma'am.
Does that make a bit more
Thank you.
sense?
Yes, ma'am.
Good. Okay, I do see the other hand. Shumi, I do see your question. We're going to deal with that situation in a second or two, so hang 10. Emanga Matanda, I'm hoping I'm saying that right. Please correct me if I'm wrong.
Okay, ma'am.
Yes.
I was gonna ask when we're dividing, we only subtract, we don't add.
Yeah, only subtraction. Addition is when we multiply.
Multiply. Okay, thank you, ma'am.
Good, well done. Okay, so guys, that's an important sort of distinction to make. When we multiply, we add. When we divide, we subtract, right? That's very, very important. So just in case anyone missed it and then I mentioned it, Shumi asked what happens if you end up with a negative exponent. We're going to come to that. So keep it in the back of your mind. We're going to get to that. I'm going to show you 2 ways to deal with it. Again, I prefer my way, but I'll show you how to deal with it. So don't stress. This also goes to someone's asked me a question of what happens if the exponent on the top is smaller than the bottom? This is going to link in with a negative exponent. So we're coming to that. Let it ruminate in your brains. You guys are on it tonight. Like, you're thinking of all the things here. I'm so proud of you. Right, let's take a little break before we get to those negative situations.
And yes, we are using S&V.
Indeed.
Signs, numbers, and variables. Woo, I love the joke, guys. I love the joke. What did one that book say to the other? Don't bother me. I've got my own problems. Can you imagine one book saying, don't bother me. I've got my own problems. Sorry, I had to laugh at this joke out loud. Thank you, Jijike. You get me. You got me. Yeah, you get me.
You guys make me laugh. Thank you, Fatima. I appreciate that. I know not everyone likes the jokes, and so I appreciate when you guys do. And if you don't like the jokes, that's also cool. It doesn't have to be for you. I just thought there was something fun to add. Yeah. Alrighty, sweet peas. So, brain break. We don't have a lot of time, so I'm not going to give you a lot of time for this brain break, like 2 or 3 minutes. Let's see if we can get an answer. If we can't, don't stress. We carry it over to Monday. So there's your brain break. I'm making it bigger so that you can see where you've got 2 rabbits, 2 hedgehogs, 2 lizards. Be careful. Remember, when it's double, we need to double the value. So I'm going to wait and see for that correct answer on the chat. Kotatso and Sanaliso have helped you a little bit with the first one, so have a look there. Always good to help each other. Well done. Noisy people right now outside my flat.
No, we can't hear anything. It's cool. Let's see who's the first person to see. Avuzwa, let's go. You're giving it a try. I can see you. I'm watching you, Avuzwa. Now I can see your face. I'm happy. Let's go. Let's go. Let's go. Let's go. Give it a try. Give it a try. Please, it's time for you to stretch, okay? So please, while you're busy doing that, stretch, because we've been at this for a long time. Just do some stretches while you're busy exercising your brain. Okay, this is just a brain break that we do, and it's very, very interesting. Okay, so we are all just trying to see if we can get an answer. So the first person to get the right answer, we call you up to come and explain to the rest of the class. Okay, that's how we actually do it. So it's very good that you get to shine because you got it first, and then you can
guys,
tell us how to do it.
Sorry, Linda, just to clarify, this is the answer we want. We want this last equation's answer. Watobe, nice.
Well done, Watobe. I'm already like jumping up and down. Well done, guys. Oh, Watobe, do you want to raise your hand so you can explain to the rest of the class how you got it? That was so fast. Okay, so don't worry, everyone who didn't get it right. Let's just listen to Watobe, and Watobe will explain step by step, okay? So that we can all get it right. Okay, guys, well done for trying. Well done.
Thank you, ma'am. So first I counted there were 3 rabbits. So I divided 27 by 3.
Excellent.
Which was 9 for
Good.
each rabbit. And then I noticed there were 2 rabbits. So I plus 9, which equaled 18.
Good.
18 times 18. I got that answer, and then I minused it from the answer, the total answer.
Okay. Good. So guys, just quickly, 18 times 18, 324. So now what Boyce is saying is 338 minus 324 will give me the little hedgehog. So Boyce, what was that answer in the end?
14. And
Good.
each hedgehog is 7. So
Excellent.
14 times 14. I did the same thing I did by the second equation.
Good.
I took 204 and subtracted by 14 times 14.
Good, which is 196 for those of you that want to know. And so you get, what were the lizards?
The lizards.
So when you said 204 minus 14 times 14, what did you end up with here? Eight?
Oh, 8, yes, ma'am.
Okay.
And then I said 18 times 7
Good.
plus 8.
Okay, why is it plus 8 or is it plus 4? There's one lizard.
Plus 4, ma'am.
Good.
And I
Good.
got
Well
130.
okay. So guys, 18
Well
times 7,
explained.
126 plus 4. Exactly the answer Boyte gave, 130. Excellent. Well done.
Well done, guys, and everyone else who tried it. Well done, my people. Y'all are awesome.
So guys, just remember BOD maths or bed maths, order of work, very, very important.
Yeah.
Well done.
Every single time before we solve it, it's good to take a screenshot, okay? So that you can play either at home with your cousins or with your brothers and sisters, or even at school during break time. Then you can give them a quiz to do, okay? It's always nice. I would love this if I was you guys.
Exactly.
Nice to feel like a genius.
No, exactly. I remember this was all the rage when we were in lockdown. Like people love doing these things.
Yeah.
Okay, guys, let us have a look at some more examples here. So where were we? See. So this is now dealing with all of those questions. What happens if it's a negative exponent? What happens if the exponent at the top is smaller than the exponent at the bottom? This example is going to look at that. So, I'm going to do this 2 different ways. Like I say, I think my way is the easier way to understand, but that's also my opinion, right? So you don't have to agree with me. If you think the law or the application of the law is easier, that's what you work with. Right, so if we apply the law 2 tells us to subtract our exponent. So this would be 2 minus 6. Now this is where I have a bit of a problem. I end up with a negative 4. It's a weird looking x. Let's try that again. A negative 4. Now in maths, we don't like negative exponents. We never ever want to leave an answer with a negative exponent. So I need to deal with that. Now I'm going to leave that there for a second, and we're going to figure out how I deal with that negative exponent. So this is not my final answer. I still need to deal with this negative exponent. We're going to come back to that. Let's have a look at a slightly different way of doing this, in that we cancel. So if we're going to cancel, we have got x squared divided by x to the power 6. If you need to expand this, that's fine. You don't have to expand when you're canceling, but if it helps you see it a little bit clearer, that's cool too. So we've got 2 x's at the top, 6 x's at the bottom. So when I go and cancel, I can cancel all 2 x's in my numerator with 2 x's in my denominator, leaving me with 4 x's at the bottom. You want to look at that expanded, 2 x's at the top, 2 x's at the bottom. I'm left with 4 x's in my denominator. Now remember, we have to write the leftovers where they sit. So because all of these leftovers sit in the denominator, I have to write the x to the power 4 in the denominator. Now because I've cancelled everything in my numerator, what I'm left with is a 1. So this actually simplifies to 1 over x to the power 4. And that therefore means that that negative exponent of x to the negative 4 actually means that my leftovers are in my denominator, and I can write it with a positive exponent. So this negative exponent situation here that I don't like is telling me that my leftovers, for lack of a better description, are in the denominator. And that's where I need to write it with a positive exponent. Now we can see that that's true through my canceling method. I canceled the 2 x's at the top with 2 x's at the bottom, and I was left with 4. My leftovers were in the denominator. I also know that's true because my bigger exponent is in the denominator, which means that my leftovers must go where the bigger exponent was, in the denominator. So there's a couple different ways that you can deal with negative exponents. Personally, I think canceling is a little bit easier to see where the leftovers go, but it doesn't matter. If you want to subtract your exponents, do it. Just remember, we don't like negative exponents, and so what it means is that we need to move our leftovers to the denominator. Okay, so I'm going to stop there in case anyone wants to take a screenshot. I'm also going to stop here for questions if anyone has any questions. We're going to have a look at another example like this. But if you've got questions, now's the time to ask me. Otherwise, you're screenshotting this.
Any questions, my people? Nkululeko, do you have any question? You look like Nkululeko and I are in the same stage. We're like in the dark and then our eyes just pops up. Okay, we have a question from Imange Mtanda.
Ma'am?
Yes.
How is it the 1 for the answer, ma'am?
In the
How do you-
numerator.
Yes, ma'am.
Okay, so I get the 1 from the fact that I've canceled everything out in my I canceled everything out here in my numerator. Now, what I need to remember is that technically these have coefficients of 1. So because I'm getting rid of those x's, I do actually have the 1 left over. I can't have nothing left in my numerator. I can't have an empty space in my numerator. So if I've
Yes, ma'am.
cancelled everything, what I actually have left is a 1.
Oh, okay. Thank you, ma'am.
Pleasure. Alrighty, guys. So I'm hoping that we have got our screenshots there. I want to do another example similar to this, just that, oh gosh. Just so that we can practice this. I'm going to make that a touch smaller. I'm just going to put a little star here because my next example doesn't cover this. So we're going to do it like this. So let's go 14x to the power 13. No, I don't want 13. X to the power 9. Oh my gracious me. Right, 9 divided by 21 x to the power 13. So we can have a look at this example here. Now what we want to do, remember, signs, numbers, variables. This is your best friend. You're going to use it forever. So I want you to try this one by yourself. See if you can apply everything that we've spoken about and everything that we've now spoken about where your bottom exponent is bigger, and see if you can get an answer for me. So give it a try. I've left question C up here so that you can see what we did. But give it a try. Put your answers on the chat.
Let's go, my people. We can do this. The last question of the day.
And remember your SNV, guys. If you remember SNV, you should be okay.
Yeah, and y'all better get it right, okay? It's the last question of the night. So you better crack your head and get it right. If you don't understand, please, I am here to help you on the chat. We can see where you're getting stuck, okay? So feel free to ask. So we are all trying. Hey, Teboho, you'll be like my person that will answer the question.
Okay, I'm going to give you another minute or so. Remember SNV?
Calvin, the question is in black. So on your right-hand side, when you're looking at the screen, the question is in black. There we go, there. That's where the question is. That's what we are doing. Following SNV, it will be easy, guys.
I just added an extra question there because I wanted us to practice this. I apologize. I should have made it clearer.
Let's go. Gudulego, I see you, girl. Your eyes are like, yes, ma'am. I'm wide awake.
What we like to hear.
Let's go. There's 70 of us, okay? We need to give 70 answers. Let's go. What are you choosing? Guys, sorry, my son is excited today, so he's making a bit of a noise.
Why is he excited?
Because he's done eating and bathing, so now he's playing with he's listening to like his favorite music and he's dancing and he's just like next door. Yeah. You don't have to use S and V. It's okay as long as you get the answer correctly. Okay. So as long as you use whatever method you understand that you feel free of, you're more than welcome to use so.
I've never seen such like aggression against SNV. I'm so sorry that it makes you angry.
I actually find it nice. And it's like still motivation, and you cannot make any mistake using SNV. Like there's no way.
So I like it as well, but like I also completely understand that it does, like just because it works for some people doesn't work for others. I would like for everyone. So
yeah,
as long as you do your, like Yolanda says, as long as you do your order of work correctly, it's fine. You don't need to use SNV.
Guys, why do I feel like we're not getting the same thing? I think maybe we should actually tell everybody to use SNV Based on the answers that y'all are giving, I'm like S&B all the way. We are all learning S&B and we're all going to love it, okay? Because the answers there they're just confusing me, even me who's like a teacher.
Okay, guys, so I'm tending to agree. We've got some weird and wonderful answers going on here, which is cool, but let's discuss it. Right, so let's start with the signs. We've got a positive divided by a positive, which means our answer is going to be positive. No argument there, our answer is positive. If we now move on to the numbers, remember the numbers are the coefficients, so the 14 and the 21. I need to ask myself, what divides into 14 and 21 without a remainder? So I can divide both of these by 7. 14 divided by 7 is 2, and 21 divided by 7 is 3. So this means that my numbers simplify to 2 over 3. I still need to deal with those variables. Now I'm going to go and deal with the variables. So the variables that I have here are my x's, and I have got x to the power 9 divided by x to the power 13. Now, two ways you can do this. Either you're going to subtract the exponents, and you're going to end up with a negative exponent, which tells you that this must go into your denominator, leaving you with x to the power 4, or you're going to cross cancel. All 9 x's cancel with 9 x's at the bottom, leaving you with 4. So again, x to the power 4 at the bottom. And so this fraction simplifies to 2 over 3x to the power 4. The x to the power 4 is in the denominator because if we look at where our bigger exponent for x was, it was in the denominator. That's where the leftovers need to go. The 2 and the 3 came from me simplifying my numbers. I can divide 14 and 21 both by 7. And so I need to simplify those numbers. Right, guys, can I just get a thumbs up, thumbs down, how we feel after I've explained that?
And out of curiosity, we just want to see who got it right.
Yeah, so I'm going to assume thumbs up, you're feeling good and you got it right.
Okay, that's okay, Khotatso. That's fine. Okay, Mfa. Yes, I'm gonna say. Okay, all right. Okay,
so
guys.
Out of interest, those of you who are thumbs downing, if you feel comfortable or if you want to send us a message, just like very briefly, what is confusing you? Just because like obviously our lesson's nearly over, but I want to make sure that you guys get this. So just for next lesson so we can recap it. What is not vibing here? What are we missing out on?
Yeah, Marco wants to help us with that. Marco, we are all yours.
Okay, so I'm new here, right? So I just wanted to ask about the S and okay. I just wanted to ask about the S&B. I don't understand it very much.
Okay, so SNV is just a way for us to correctly multiply and divide. It just breaks it down for us. So basically, we deal with the signs first. Positive divided by a positive is a positive. So I know my answer is positive. Once I've dealt with the signs, that's dealt with. I move on from that. Then I go on to the numbers. So 14 divided by 21, I simplify that to get 2 over 3. And then I move on to my variables, the x to the power 9 divided by x to the power 13, and I apply my law. So all it is just breaking down your multiplication and division into steps so that you're correctly getting your answer. That's really all it is. You don't have to use it, like not at all. It's just quite helpful, especially when our fractions or our products get quite complicated. It's helpful to be able to break it down.
Very helpful. Mutabang, you next. You can ask your question.
Ma'am, may you please explain? Ma'am, may you please explain about how do we get the answer?
Okay, so which part is a bit confusing?
Ma'am, I think the N and the V.
Okay, cool. So for the numbers, I've got 14 and 21. I can divide both of those by 7. So 14 divided by 7 is 2. So I've got my 2 in my numerator. And 21 divided by 7 is 3. So I put the 3 in the denominator because the 2 came from the 14 in the numerator. The 3 came from the 21 in the denominator. So they go where they came from. Then for the variables, I've got 9 x's at the top and I've got 13 x's at the bottom. That means I can cancel all 9 x's at the top with 9 x's at the bottom. But then I've got an extra 4 x's that I can't cancel from the 13. And so that's why I've got the x to the power 4 left in my denominator. Does that make a bit more sense, Motabang?
Yes, ma'am. Thank you. I understand now.
Good. Well done.
Nice. Nice. Okay, so Didintle, guys, we're running out of time. So I see there's Didintle and Litesh. Let's quickly get them. Didintle, you can unmute and ask.
Ma'am, 9 minus 13 is -4, ma'am. But at the denominator at 3, ma'am, you said x4. Isn't it supposed to be x -4?
Okay, so remember, there's my -4 over there. That negative is telling me that I should put it in the denominator. And so when I put it in the denominator, it becomes positive. It changes the position of my value in the fraction, making it positive because we don't like negative exponents. So just to like say it again, this negative, gosh, sorry, this negative is telling me to write with a positive exponent, but in the denominator. It's telling me to put my remainder in the denominator. Okay, Didintle, I hope that makes sense.
I think
Litesh?
Didintle unmuted. Yeah, Litesh, it's your turn.
Ma'am, then in 14 you divide by 7, and in 21 you divide by 7, then it's going to make 2/3. Then you
Yes.
go to x to the power 9 and to the x to the power 13. Then you minus. Then you minus 9 to 13. Then it's going to be -4. Then you said 2/3 x to the power 4.
Good.
Then it's going to be 2/3 x to the power 4.
Perfect.
Nice, Litesh. Okay, guys.